Hi everyone, and welcome back. In this video, I'm going to be going over the 2015 AP Physics 1 FRQ number 1, and let's just get right into it. So this is problem 1, and it was worth 7 points, and the suggested time was 13 minutes. And as we can see here, the problem states that two blocks are connected by a string of negligible mass that passes over massless pulleys that turn with negligible friction. So the mass of the string and pulley and the friction can be neglected, so we don't care about those. And then it's important to note that the mass M2 of block 2 is greater than that of block 1, and the blocks are released from rest. So question A says that the dots below represent the two blocks, and it asks us to draw free body diagrams showing and labeling the forces, not components, exerted on each block. And it's important to draw the relative lengths of all the vectors to reflect the relative magnitudes of all the forces. So let's start with block 1. We know that block 1 has only vertical forces acting on it, no horizontal forces. And the only vertical forces acting on it are the force of gravity and the tension from the string. And let's start with the force of gravity. So the force of gravity acting on block 1 must be less than that acting on block 2, because mass of block 1 is less than the mass of block 2. So let's go ahead and draw a short arrow for the force of gravity on block 1. And then we can turn to block 2 and draw a longer arrow for the force of gravity acting on block 2. Now, both blocks have the same tension force acting on it because it's the same pulley and the friction is negligible, so the tension will be the same for both blocks. And the tension should be greater than the force of gravity on block 1, but less than the force of gravity on block 2 so that the system accelerates in the right direction. So now notice the relative lengths of all of these. The tension forces are the same length, and that is greater than the length of the force of gravity on block 1, and all of those are less than the force of gravity on block 2. Okay, now moving on to question B, which asks us to derive the magnitude of the acceleration of block 2 in terms of m1, m2, and g. So we can start off by writing separate equations for mass 1 and mass 2. So mass 1, using Newton's second law, we can say that m1 times acceleration is equal to the tension minus m1 times g. And similarly, m2 times a equals m2g minus t, and we're taking the positive direction for each of these equations to be the direction in which they would be accelerating. Now, combining those equations and eliminating t and isolating t, we get that t equals m1a plus m1g from the first equation, and combining that with the second one, we get that m2a equals m2g minus m1a minus m1g. And rearranging, we get that m2 plus m1 times a is equal to m2 minus m1 times g. And now we can solve for a, which gives us m2 minus m1 times g all over m2 plus m1. Now moving on to question C, which says that let's say that hypothetically, block 3 of mass m3 is added to the system, and there is no friction between block 3 and the table. So let's go ahead and see what forces are acting on block 3. So we know that there is a tension force pulling in both directions on block 3, and that would mean it would cancel out. And then in the vertical direction, there's the weight and then the normal force. And because it's not moving or accelerating in the vertical direction, those two also cancels out, which tells us that the net force acting on block 3 is 0. So it makes no contributions in the vertical or horizontal direction of the net force on the system. So we can write the same system of equations as we did for the last one with a little change. So here, the tension minus the force of gravity on block 1 plus the force of gravity on block 2 minus the tension is equal to the sum of all three masses times the acceleration of the system. And now the tension on both sides cancels out, which gives us that the acceleration is equal to m2 minus m1g all over m1 plus m2 and plus m3. And this is smaller than the original acceleration because there is more mass now. Mass 3 contributes extra mass to the system. Okay, so that was it for question 1 of the 2015 AP Physics 1 FRQ. Come back for more later, and we hope you've learned something new.